Windows has long been the go-to platform for gamers, boasting a vast library of titles across various genres. But have you ever considered emulating Windows itself? With advancements in technology, this is now a reality, allowing you to experience the legacy of Windows gaming in new and exciting ways. Whether you're revisiting classic games or exploring new ones, the possibilities are endless. I remember when trying to run Windows on a mobile phone felt like chasing an impossible dream. Back in the day, you had projects like Renegade, and for a while, it seemed like that was our only shot. But man, was it a nightmare. The process was so complicated, just constant tweaking and frustrations, and at times, it really tested your patience. And GTA 5 on mobile? That was the ultimate clickbait on YouTube. It sounded more like a joke than anything real. But surprisingly, what seemed impossible started to become a reality. It wasn't overnight, but Windows emulators were slowly changing the game. The first major breakthrough? Exagear. It was like someone cracked the code for running Windows games on Android. After that came Mobox, which pushed things even further. But what really flipped the script was Winlator. Now, it might not be stronger than Mobox, but it's a much easier setup, becoming a go-to for people like who don't know a thing about these emulators. Hey everyone, it's Kuro. Today we're diving into Winlator Emulator. I've got some gameplay showcases for you, we'll talk about the settings, and I'll be sharing some things about Winlator that you probably won't hear anywhere else. I'll be upfront, I'm not a huge tech expert, but I've done my research and I feel good about walking you through this. Of course, if I slip up, don't hesitate to correct me in the comments. For those who aren't familiar with it, Winlator is based on something called Wine. Wine is basically a tool that lets you run programs made for Windows on other systems like Linux or Android. What's cool about Wine is that it doesn't work like your typical emulator. Normal emulators try to recreate an entire system, which can make them slow and clunky. Wine skips that. Instead of trying to be Windows, it just translates the Windows instructions into something your Android device can understand. That's why it's way faster and more efficient compared to traditional emulators. Let's break this down a bit more. When games are made, they use something called a graphics API, which stands for Application Programming Interface, to talk to your device's graphics card. Older games usually use DirectX 9, while newer ones go with DirectX 11 or 12, which are all part of Microsoft's DirectX. Then there's Vulkan, a newer API that's designed to work across different systems, especially on devices that aren't running Windows. Winlator uses something called DXVK, which bridges these APIs together. Whether the game uses DirectX 9 or something more modern like DirectX 11 or 12, DXVK handles that transition to Vulkan. And that's what helps Winlator make these games work so well on mobile. Alright, enough talking. Let's jump into some gameplay. Now, I tested a bunch of games, but I'll admit not all of them worked. Some that I saw other YouTubers run, I just couldn't get them to boot. I think I'll need to spend a bit more time figuring it out. I did get some help with the settings from a few YouTubers, and I'll link them in the description if you want to check them out. Tomb Raider 2013. This one ran surprisingly well, hitting around 40 to 45 FPS, which is crazy considering I'm running this on a mid-range tablet. Just Cause 2. Another solid performance, running between 35 and 40 FPS. Bioshock and Prototype. Unfortunately, I couldn't get these to work, but I'm not giving up on them yet. Need for Speed Most Wanted 2012. The FPS bounced between 30 and 45, but honestly, it felt pretty smooth while playing. Assassin's Creed Rogue. This one was super smooth, hitting between 40 and 45 FPS. It runs even better than the Switch version. There is a weird glitch with the controller where the D-pad seems to press itself, which is something to watch out for. Metal Gear Rising: Revengeance. Didn't run as smoothly as the others, but it was playable, which was a win for me. If you're still here and enjoying the video, be sure to hit that subscribe button and drop some feedback in the comments. Let me know what you liked and what I could do better in the next one. Far Cry 2. Again, smooth performance, but I ran into that same controller glitch. But I wanted to milk out every inch of power from Winlator, so I tested the most power-demanding game of all time. Summertime Saga. To my surprise, this game runs at full 120 FPS, which I never imagined my mid-range tablet could ever do. Now we'll move on to the settings section, so keep your focus here. Mouse section. Cursor speed. This controls the speed of the mouse cursor or the arrow. Cursor size. Customize the size of the cursor or arrow on your screen. Move cursor to touch. This option replaces the cursor with your touch point. This setting is ideally made for games like visual novels, point-and-click games, and summertime saga-type games. However, it's not very accurate right now, so I wouldn't recommend using it. Preferred Input API. Here's where it gets interesting. You can choose between D input and X input. Direct input is generally used for older games and supports a wide range of devices, but it can be complex to set up for newer controllers. X input is tailored for Xbox controllers, offering simpler configuration and better support for features like vibration feedback. Most newer games favor X input due to its ease of use, but don't expect vibration to work on Winlator. For most users, it's best to leave this setting on auto, or both. Advanced section. Box64 version. Box64 is a compatibility layer that allows you to run 64-bit applications on devices that don't natively support them. It's especially useful for running more demanding games on lower-end hardware. So in this setting, you usually want to keep it on default, but sometimes you might need to change to a different Box64 version depending on the game you're trying to run. Box64 preset. This part is a game changer, and one of the most confusing settings. Many people don't explain this part, which is quite sad because it could easily warrant its own separate video. If you don't have a very strong mobile device, most problems tend to arise from this part, so don't skip this section just because it seems boring. I'll try to explain every inch of this part in a way that even the dumbest person like me probably will understand. The Box64 preset optimizes the emulator's performance by adjusting settings tailored to your device's capabilities, making it easier to run a wider range of games smoothly without requiring manual configuration. In this section, you'll find some presets provided by Winlator: stability, compatibility, intermediate, and performance, which are quite self-explanatory, but I'll explain them just in case. Stability. This preset prioritizes making sure games run without crashing, even if it means sacrificing performance. Compatibility. Focused on getting as many games to run as possible, even if they don't run at peak performance. Intermediate. This is a balanced option that offers a middle ground between performance and compatibility. It's a good choice if you want decent performance without sacrificing too much compatibility. Performance. This preset aims for the highest performance, allowing for better frame rates and responsiveness, but it may result in some games being less stable or crashing. But I don't recommend using any of these presets most of the time because they are tweaked for general devices. I and Winlator itself suggest you customize settings tailor-made for your individual device. That's why they provide customization options. When you click this plus icon, you can create a new profile for the Box64 preset, or use the pencil icon to edit a pre-existing profile. After clicking either, you'll find many settings that may seem complex if you are not a technical person like me. So now I'll explain each of these settings, so keep your focus because it can get confusing, but I'll try to explain in an easy way. Box64 Dynarec Safe Flags. Before we dive into this setting, let's first understand the Dynarec engine. Dynarec stands for Dynamic Recompiler, which is a key part of many emulators. Its job is to convert code from one platform, like Windows, to another, such as a mobile device. This setting controls how many safety checks the Dynarec engine performs. In Winlator, there are 3 safety levels to choose from. Level 0, this prioritizes performance, giving you more speed but at the cost of stability. Level 1, a middle ground option that balances both performance and stability. Level 2, the safest choice, improving stability but potentially reducing performance. By understanding these levels, you can decide what's more important for your needs: speed or reliability. Box64 Dynarec FastNAN. Now let me explain what NAN is. NAN stands for not a number, and it represents a value that doesn't make sense or simply can't exist. For example, you can't divide 3 by 0. It's like trying to split 3 apples among 0 people, which is impossible. When something like this happens in a program, it results in NaN because the answer isn't a valid number. Programs rely on numbers to function correctly. And if NaN somehow sneaks into the program, it can cause all sorts of problems. Imagine NaN as the spoiled kid and the program as the good kid. If the spoiled kid hangs out with the good kid, it could mess up everything. To prevent this, the emulator acts like a parent, keeping NaN separated from the program to avoid crashes or glitches. This particular setting helps the emulator separate NaN values more quickly, improving game performance. However, this comes at a cost. The game's accuracy might be compromised. If you turn this setting off, the performance might slow down, but the accuracy will improve. So, I suggest you keep this setting on if you need better performance, and the accuracy is acceptable. In Winlator, most games don't have accuracy problems, so typically you should keep this setting on. Box64 Dynarec FastRound. First, let's discuss floating point numbers. These numbers can represent very large values, like the distance from the Earth to the Moon, or very small ones, such as the size of a human cell. In programming, these floating point numbers need to be represented in code, which can sometimes be complex and confusing. To simplify calculations and enhance performance, the code rounds off these floating point numbers. This setting specifically enables the emulator to round off these numbers more quickly, facilitating faster processing and improving overall performance. However, it's important to note that while this rounding speeds up calculations, it can also lead to a loss of precision. This lack of accuracy may impact gameplay mechanics, graphic rendering, animation smoothness, and AI behavior. Fortunately, in many cases, these effects are minimal and often go unnoticed. Therefore, it's generally advisable to keep this setting enabled for better performance, as the benefits usually outweigh any minor accuracy issues. If I keep telling technical programming stuff, the video will reach an hour long and will get super boring for you guys. So from this part, I won't go into technical programming stuff and just tell you what this setting does, but if you guys are interested, let me know. Box 64 Dynarec X87 Double. This is just double accuracy settings. If you enable this setting, the game will have high accuracy but lower performance. Box 64 Dynarec Big Block. This is just a RAM usage setting. If you keep it high, the game will run smoothly in exchange for using more RAM. Winlator provides 4 levels. Level 0. This is the lowest setting, using minimal RAM. As a result, performance will be lower, with slower processing and less smooth gameplay. Level 1. A step up from Level 0, this setting slightly increases RAM usage, leading to better performance and smoother gameplay, but still conservative in memory consumption. Level 2. This level uses a significant amount of RAM. The performance boost is quite noticeable here, offering smoother gameplay, faster loading, and more consistent performance in exchange for high memory usage. Level 3. The highest setting. This level allows the emulator to use the most RAM available. It provides the best performance possible with the smoothest gameplay, fastest processing, and least lag. However, it demands a lot of memory and may not be ideal for devices with limited RAM. Dynarec Strong Mem. This setting gives you better stability but at the cost of performance. Disabling it improves performance but may reduce stability. Depending on the game you're playing and your device's capabilities, you can decide which setting is more suitable for your needs. It also has 4 levels. Level 0. This completely disables strict memory access checks, prioritizing performance over stability. Games will run faster, but there's a higher risk of instability, including crashes or glitches. This is best for games that are known to run well without needing extra stability measures. Level 1. At this level, the emulator performs minimal memory checks. It strikes a balance between performance and basic stability. The checks are light, so it helps prevent some memory-related errors, but performance still remains a priority. Level 2. This level increases the strictness of memory checks, favoring stability more. The emulator now performs more frequent and detailed memory checks, ensuring fewer memory access errors. As a result, stability improves, but performance can take a hit. Level 3 Maximum. This level enforces the strictest memory access checks. It is designed for maximum stability, especially for games or programs that are prone to memory access issues. However, it significantly impacts performance as the emulator constantly monitors memory operations. This setting is best used if you're encountering crashes or instability in specific games. Box 64 Dynarec Forward. Before we dive into this setting, let's set some context. The Dynarec engine, which I mentioned earlier, is responsible for translating game instructions to run games smoothly. When you allow this engine to use more processing power, it can look ahead at future game instructions, which improves performance and rendering quality. Think of it like studying for an exam. If you allocate more time to your studies, you can cover extra chapters, leading to a smoother exam experience. However, just like studying requires the right approach, using more power also necessitates a capable device. If you try to overextend yourself on a less powerful device, you might end up regretting it. Similar to how cramming for exams without proper time management can lead to stress and poor results. This setting has 5 levels: 0, 128, 256, 512, and 1024. Level 0 Disabled. The Dynarec engine doesn't look ahead at all. It translates instructions one at a time, which can be slower but uses the least memory and processing power. Level 128. At this level, the engine looks ahead at 128 instructions, which improves performance without overloading resources. It strikes a balance between speed and efficiency. Level 256. Here, the engine looks further ahead, 256 instructions, enhancing performance even more, but it requires additional memory and processing power. Level 512. At this level, the engine translates a larger chunk of instructions, 512. While this makes the game run significantly faster, it demands considerably more memory and processing power, so you'll need a capable device. Level 124. This is the maximum setting, where the engine looks ahead the most, 1024 instructions. It maximizes performance, but comes with a high cost in memory and processing overhead. This level is ideal for powerful devices that can manage the extra load. Each level provides a choice between faster performance and conserving resources, depending on what your device can handle and the demands of the game. If your device has a powerful processor like the Snapdragon 8 Gen 2 or 8 Gen 3, you can comfortably set it to 1024 without issues. Since most of my subscribers have Snapdragon 860, I recommend using a setting between 128 and 512. Going beyond that may lead to unnecessary stress, just like overthinking during exams. Box 64 Dynarec Call Ret. Enabling this setting can enhance the stability of certain applications by ensuring that these call and return instructions are executed accurately. This can help prevent crashes or unexpected behavior during gameplay, especially in games that rely heavily on complex function calls. However, the trade-off is that it may reduce overall performance, as the emulator has to spend extra resources to ensure this accuracy. Overall, whether to enable or disable this setting depends on the specific games you are playing and your need for stability versus performance. Box 64 Dynarec Wait. This setting allows the Dynarec engine to wait for specific instructions. When enabled, you'll experience more stability at the cost of performance. Conversely, if disabled, performance improves, but stability may decrease. Then there's the Wine version, which most of the time you want to keep at default. But you can change the Wine version by downloading different Wine versions from GitHub and pressing this down arrow icon. Screen size. When it comes to screen size, two important factors to consider are aspect ratio and resolution. The most common aspect ratios are 4:3 and 16:9. With a 4:3 aspect ratio, you might notice black bars on the sides of the screen, which can detract from the viewing experience. On the other hand, a 16:9 aspect ratio typically eliminates these sidebars, but depending on your device, you may still encounter black bars at the top and bottom. A potential downside of using a wider aspect ratio is that it can sometimes cause character stretching, making characters appear shorter or distorted. Resolution is another crucial aspect. The higher the resolution, the clearer and more detailed your emulator games will look. However, keep in mind that increasing the resolution demands more processing power, which can impact your device's performance and battery life. Before explaining the graphics driver, I want to introduce the DX wrapper for better understanding. DX wrapper. As I mentioned earlier, API stands for Application Programming Interface, which is a set of rules and tools that acts as a bridge between a game or application software and the hardware, such as the GPU or CPU. It helps the game or app send instructions to the hardware without needing to directly control it, making the communication process smoother and more efficient. Let's go over the key APIs used in Winlator. We'll start with the APIs created by Microsoft, specifically DirectX 1.7, DirectX 9, DirectX 11, and DirectX 12. DirectX 1.7. These early versions were designed for older 2D and 3D graphics technologies, mainly used in games from the late 90s and early 2000s. For example, Age of Empires or Diablo used these older DirectX versions. DirectX 9. Introduced in the early 2000s, this version revolutionized game graphics with better lighting, shaders, and more detailed 3D models. Popular games like Half-Life 2 and World of Warcraft were built on DirectX 9. DirectX 11. This version brought major improvements in performance and graphics quality, supporting advanced visual effects and efficient multi-threading. Games like Crysis 3 and The Witcher 3 took full advantage of these features. DirectX 12. The latest version, DirectX 12, focuses on reducing overhead and improving CPU and GPU utilization. It provides low-level access to hardware, maximizing performance in games like Forza Horizon 5 and Cyberpunk 2077. These are collectively called the DirectX series. Now, let's talk about the APIs you'll find on mobile devices. OpenGL and Vulkan. OpenGL, Open Graphics Library, one of the oldest and most widely supported graphics APIs. OpenGL was created in the early 1990s by Silicon Graphics. It allows developers to render 2D and 3D graphics by interacting with the GPU. OpenGL is cross-platform, meaning it can run on multiple operating systems like Windows, Linux, macOS, and Android. Classic games like Quake 3 Arena and Minecraft were built using OpenGL. However, OpenGL is considered less efficient than more modern APIs, as it uses more CPU power and has higher overhead, which can slow down performance. Vulkan, a newer API developed by the Kronos Group, the same group behind OpenGL, Vulkan offers much better performance. It gives developers low-level control over the GPU, allowing for optimized interactions between games and hardware. This results in more efficient use of multi-core CPUs and overall better performance. Vulkan is also cross-platform and supports modern operating systems like Windows, Linux, and Android. More demanding games like Doom 2016 and Red Dead Redemption 2 use Vulkan for its speed and efficiency. Now that we've covered the key APIs, we can talk about the DX wrapper or DirectX wrapper. This setting allows you to translate DirectX instructions to your device's API, either Vulkan or OpenGL. You'll need to choose the API based on your device, which you can check using apps like CPU-Z or by Googling your device's API. Winlator offers 4 options for the DX wrapper, and I'll explain each one. WinD3D. WinD3D is a DirectX to OpenGL wrapper. It converts DirectX 9, 10, and 11 calls into OpenGL, allowing DirectX games to run on systems that support OpenGL. This is best for systems where OpenGL is more stable or better supported than Vulkan. However, it generally offers lower performance compared to Vulkan-based solutions. If your device supports OpenGL but struggles with Vulkan, this might be your best option. DXVK is a DirectX to Vulkan wrapper that translates DirectX 9, 10, and 11 calls into Vulkan API calls. Vulkan offers better performance and lower overhead than OpenGL. This is best for systems with strong Vulkan support. DXVK often provides superior performance compared to WinD3D, especially in demanding games. Use this if your device supports Vulkan and you want better performance in DirectX 9 to 11 games. VKD3D. VKD3D is specifically for DirectX 12 to Vulkan conversion. It's designed for running DirectX 12 games on non-Windows platforms with Vulkan support. If you're playing a DirectX 12 game and your system supports Vulkan, VKD3D is the right choice. However, DXVK is generally the better option for most other DirectX versions. CNC-DDraw. CNC-DDraw is a wrapper specifically for DirectDraw, DirectX 1.7 games, translating them to either OpenGL or DirectX 9. Many older games rely on DirectDraw, which is no longer supported in modern Windows versions. This is best for running older DirectDraw-based games. Now that we've covered all the APIs, we can move on to the graphics drivers. Graphic driver. The graphic driver settings determine how the emulator communicates with your device's hardware to render images and animations. Different graphic drivers offer varying levels of compatibility, performance, and visual quality. In Winlator, there are 2 graphic driver options. Turnip. This is an open-source Vulkan driver for Qualcomm Adreno GPUs, used in Snapdragon processors. It offers better performance and compatibility with devices that support Vulkan. If your device has a Qualcomm processor, Turnip should provide smoother performance and potentially better graphics output in games. It's the preferred choice if Vulkan is supported on your device. Virgil. This is an open-source driver that allows 3D rendering over a virtual machine, VM. It's commonly used in virtualized environments to emulate OpenGL. VirGL isn't as fast as Turnip and may be less efficient, but it can help run games that don't work well with Vulkan, or if your device doesn't fully support the Turnip driver. If you have a Snapdragon device with Vulkan support, choose Turnip for better performance. Use VirGL if you encounter compatibility issues with Turnip, or if your device doesn't support Vulkan well. Now I'm really tired your subscription and would be very appreciate for more content like this. Audio driver. To be honest, you don't want to do anything in this setting, but sometimes I see people saying changing the driver helps them, so I'll just explain a little bit. This audio driver setting controls how sound is handled by the emulator and your device's hardware. Just like with graphics drivers, the right audio driver ensures better performance, audio synchronization, and overall quality during gameplay. Winlator offers 2 main audio driver options, ALSA and Pulse Audio. But I'll tell you about latency, which is just delay in sound. For the human ear, 20 to 30 milliseconds is enough, but here in the game, 40 milliseconds is enough. ALSA, which stands for Advanced Linux Sound Architecture, is best for devices where minimal audio latency is important. Pulse Audio, best for devices where advanced audio processing or the ability to mix sounds from multiple apps is needed, but it may come with slightly higher audio latency compared to ALSA. Inside audio configuration, you will find Performance Mode, where you can choose between 3 modes. None. General use, when you don't need to optimize for either latency or battery life. Low latency. Action-packed games or scenarios where immediate sound feedback is important, such as shooters or rhythm games. Power saving. Long gaming sessions, or when you're trying to conserve battery life on low-power devices, especially for games where sound latency is less critical. Below this, you will find volume and latency, which is very self-explanatory. Desktop section. This section has nothing to do with games. It's just for aesthetic customization, so I won't cover it. GPU name. This option allows you to choose a virtual GPU, which can be useful because some games have minimum GPU requirements to run properly. For example, Sleeping Dogs requires at least an NVIDIA GeForce 8800 GT or higher. In such cases, this setting might help. However, you can't simply select an RTX 3070 if your device doesn't have the power to support it. It could lead to performance issues or crashes. Off-screen rendering mode. This setting is just talking about the back buffer. So first let me explain what a buffer is. A buffer is like a temporary storage space or waiting area for data, like images, sounds, or information, that needs to be processed or used. Imagine you're waiting to watch a video on your phone. Instead of showing the video all at once, your phone loads a little bit ahead of time and keeps it in a buffer. This way, when you press play, it can play smoothly without pauses or delays. 2 options. Let me explain each. Back buffer. Think of the back buffer as a waiting room for images before they are shown on your screen. When a game or application wants to draw something, like a character or background, it first paints it in the back buffer. Once everything looks good, the back buffer is quickly swapped with the front buffer, the part you're currently seeing. This helps prevent flickering and makes the images look smoother. FBO Frame Buffer Object. An FBO is like a special type of back buffer that allows more flexibility and options for rendering. With an FBO, you can create multiple buffers that can store different types of images or effects. This means you can do things like apply filters, combine images, or create special effects before displaying the final result on the screen. It's often used in more complex graphics tasks. Basically, an FBO is just the Super Saiyan version of a buffer, like Goku, which needs more power. Video memory size. Video memory, VRAM, is a type of memory used by the graphics card, GPU, to store image data, textures, shaders, and other graphical information necessary for rendering images and video. The size of the video memory can significantly affect the performance and quality of graphics in games and applications. The more, the better, but your device should be capable, so choosing the right amount is the best. 32 MB, suitable for very old or less demanding games. Limited graphical fidelity may struggle with modern titles. 64 MB can handle basic graphics for older games, may start to show limitations with more demanding 2D or early 3D games. 128 MB, better suited for older 3D games and some indie titles. Can run many classics, but may struggle with modern textures or high resolutions. 256 MB, more versatile, can handle a wider range of games. Allows for decent quality settings and moderate resolution without significant performance drops. 512, good for most games from the late 2000s and early 2010s. Supports higher resolution textures and effects, making it a solid choice for a variety of titles. 124 MB, 1 GB, suitable for modern games, particularly those from the last decade. Provides good performance with higher graphical settings, ideal for many mid-range gaming setups. 2048 MB, great for more demanding titles and games with rich graphics. Allows for higher frame rates and better visual quality. Suitable for gaming at higher resolutions. 4 GB. Ideal for the latest AAA games and high-resolution textures. Ensures smooth performance even with high settings and in graphically intense situations. Enable CSMT, Command Stream Multi-Thread. This setting helps spread the workload across multiple CPU cores, which can lead to smoother gameplay and improved frame rates, especially in games that are heavy on graphics processing. However, the performance benefit depends on the game and your device's hardware capabilities. Strict shader math. Strict shader math makes sure the calculations in the game's graphics are as close as possible to how they would be on real hardware. This can help prevent visual glitches or bugs in some games. However, it can also slow down performance because it forces the emulator to be more exact and less optimized. Disabling it can give a performance boost, but may cause minor graphical issues. Advanced section. Startup selection. Startup selection offers 3 modes to control how many services are loaded when starting the emulator. It has 3 modes. Normal loads all services, which means the emulator starts with everything running. This mode provides full functionality, but may consume more system resources. Essential. Only the most necessary services are loaded. This mode strikes a balance between performance and functionality, ideal for general use without loading unnecessary services. Aggressive. Stops most services during startup to free up resources, focusing on maximizing performance. This is best for low-power devices or situations where you need the emulator to run as smoothly as possible, but with limited features. Windows version. Just use Windows 10. Processor affinity. Processor affinity controls which CPU cores are used to run the emulator. By limiting or assigning specific cores, you can optimize performance, manage heat, and conserve battery. If you assign fewer cores, e.g. 2 or 3, the emulator may run slower, but you'll save battery life and prevent overheating. If you assign more cores, e.g. 7, the emulator may run faster and more smoothly, but it could cause higher battery drain and heat production. For most users, it's best to use all available CPUs unless you're trying to conserve battery or reduce overheating. Processor affinity, 32-bit apps. This is the same story for 32-bit apps. So that's the complete breakdown of Winlator from me. How was it? Let me know in the comments. I did my best to explain every section of the settings that I believe is crucial for unlocking the full potential of Winlator. Thanks for watching. If you want to learn about the best 3DS emulator, click on this video here. Or if you're curious about the best PS2 emulator, check out this video. And before I go, don't forget to hit that subscribe button for more in-depth content like this. This is Kuro, signing off.